Welcome to the Crazy Hat Chemist. So another video here on thermochemistry. So let's get moving. Bam! So today we're talking about Hess's law of heat summation. What is that? So Hess's law is the algebraic sum of two or more reactions. And this sum is no different than if the reaction were to occur in a single step. Okay, this concept allows us to calculate delta H naught of formation. That's delta HF naught, delta H naught of formation. We talked about that already, the molar heat of formation. Values that are difficult to experimentally determine via an indirect approach. Okay, so here is an analogy. This is actually a mountain pass in Italy here that bicyclists do. Okay, and it's very steep. So one, you could climb the mountain pass via a cable, and that would be a one-step process. So if you go from this low point to the high point, boom, via cable, one-step process, not a problem. Well, in chemistry, many times that one-step process of a reaction is very, very difficult to obtain or just impossible to do, okay, under the laboratory conditions of which we have. So what we have to do is find multiple different reactions which add up to the same thing. So ultimately, I want to start at the bottom of this and I want to end at the top of it. Okay? So climbing a mountain pass using the switchbacks and taking rest along the way is a multi-step process, that approach. So let's follow the mountain pass here. We're going to start at the same place there. We got 1, 2, 3, 4, 5, and 6 steps. But you notice that these 6 steps, they start and they end at the same place as the one-step process. So when you start and you end at the same place, it doesn't matter how many steps you take, that is called a state function. So your bank account is a perfect example of a state function. If you have $100 in your bank account, it doesn't matter if you added $1 every day or if you added $100 all in one lump sum. Or if you added $1,000 and took out $900. The ultimate ending result is that you end up with the $100 in your bank account, supposing that you started off with 0 to begin with, right? Because you start and end at the same place. Okay, here's an example of this using a chemical reaction. At the very top here, I got carbon, that's a solid, oxygen, that's a gas, and ultimately I want to get carbon dioxide, that's a gas. Now, we can do this in one step, and the delta H of this is negative 393.5 kilojoules. So let's say we can't actually do this in the laboratory example, okay, but we're going to have to take an alternate approach to it. And that is, we're first going to go from carbon solid and oxygen, and we're going to get carbon monoxide. Once we get the carbon monoxide, then we're going to add a little bit more oxygen to it, and then we're going to get the carbon dioxide from the carbon monoxide and excess oxygen. So that is what we have here. Notice that we end at the same place and we start at the same place. So that's the point. That first step of the two-step process that's highlighted in red and orange, the enthalpy change is negative 111 kilojoules, and then the second step of that is negative 282.5 kilojoules. So if you add those up, you're going to get the same value as what we had in the blue at the negative 393.5 kilojoules. If they don't add up exactly, they are really, really close that they are insignificant. Okay? That gives you a basics of the Hess's law, heat of summation. So you notice that we cannot do it in one step, but we can do it in multi-step processes. Okay? I got a great hat here for you. I am the king of chemistry videos here. Give me a thumbs up if you like it. Subscribe to my YouTube channel. And I got a great website with lots of great worksheets set up for you. So I'll see you next time. Bye for now.